Now we have what I think will be one of the highlights of today, a conversation with the father of Causal AI, Judea Pearl. I had the pleasure to fly to his home in LA and record something specifically for this event. So we're going to now play that recording, aired live here for the first time. And we certainly hope to have Judea at other events as well. Hopefully, we'll come next time closer to his house so we can have him in the real world too. So enjoy, guys. So Judea, first of all, thank you so much for hosting me here in your office in Los Angeles. To get us warmed up, if I was a data scientist or a researcher doing deep learning, and I found good results for it, and I'm very happy, and someone comes and says, hey, you should also do causal AI. What would Judea say to that?
From deep learning, well, deep learning can give you answer to a very limited class of questions. And everything depends on the question that you want to ask and the answers that you want to get. So in deep learning, you get essentially a functional approximation. That's what deep learning gives you. Okay? So if you want to find the approximation to a probability function, maybe the conditional probability of of interpretation given a scenery, that will give you provide you a good, effective method of going from the input to output. But if you want to go and ask more sophisticated questions, like we do in everyday life, if you want to read and understand a story in the New York Times, or communicate with any social scientist or political scientist, you're talking about cause and effect. What causes what? What will happen if I do? And can you explain to me why I got sick? So this is the kind of questions that form what we call the ladder of causation, that deep learning cannot give you an answer to unless you insert all the answers explicitly, all the answers that you ever gone, all the questions and the answers, like in a Chinese room of servers, right? You make a long list of all the answers and all the questions that you anticipate to ask in the future. But this, of course, takes a lot of memory and computation to get. So we perhaps one day we will be able to do it and just approximate that ideal of a Chinese room with a functional approximation. We're not there yet. So because it's super exponential.
Right.
All possible questions, including causal question, including counterfactual question. It's super exponential. So we have to have a encoding, a parsimonious encoding that will generate for you the answer to a class of questions you anticipate asking. That is what causal models are. Yeah. It's a parsimonious representation of world model which can generate the answers to questions. So you notice that I'm talking about answers to questions, and I'm not talking about what other people are talking about.
Yeah, of course. And often we get asked this question. Obviously, Bayesian networks. You are the inventor of them, but we often get asked question of, I'm doing Bayesian stuff. Why do I need causal stuff? Why can I not get away with just a Bayesian reasoning engine?
What is Bayesian? Bayesian is still built on statistics, on probability theory. It's just you invert the the joint probability. You express it in two different directions: x given y or y given x.
Yeah.
But both of them are computable from the joint probability of x and y. So it's all still within the framework of probability theory. Nothing could be done outside probability, which is speak the language of probability.
Yeah.
You need to have a new language. So therefore, you cannot do with Bayesian. Although interesting, historically speaking, Bayes himself was motivated by causal consideration. He wanted to prove, according to Price, the existence of the deity, the final cause. So what kind of evidence we need to prove that Jesus was indeed resurrected?
Interesting.
How much evidence you need for that?
For that?
Yeah.
Oh, wow. I didn't know. Wow, it's fascinating. Amazing. So, so I think you're effectively saying Bayesian approaches are just tweaking, statistics. Trying to be smart. It fits into the trying to be smart statistician bucket, but doesn't quite solve these really important problems. It doesn't allow us to climb the ladder.
It doesn't allow, and you can tell it right away. You read a paper, you can see what language is, what notation is used in the paper.
Right.
If it has notation of probability, you can put it down. no, really. Put it down means it belongs to the
that bucket. Yeah.
First layer of the ladder.
Yeah.
It's highly useful. Look,
of course.
You know how many statisticians are making living on that?
Of course.
Okay. It's useful, but it doesn't allow you to climb the ladder. Okay.
Very nice.
Sometimes you take a paper and you see notation like do notation. You see, already has.
Now we can understand the impact of doing something today on our business or
on a business tomorrow.
Yes.
Okay. But if you see take a paper and you see counterfactual notation, it is peculiar by the use of subscripts. Y sub x.
Awesome.
That gives you the third level.
I think that's a really nice summary and some really tangible examples there. Thank you so much. When I visited you here last time, you told me that we have a serious problem, and that is the lack of data scientists trained in causality.
Correct.
And I think that problem still persists today. Do you have any solutions in mind? Do you see any? Maybe let's start there.
Here is a problem. I can at UCLA produce 1 or 2 PhDs a year. Okay? You know how many PhDs a year data science produces? I wouldn't be exaggerating if I say 5,000 a year.
Right.
Okay? Because what does it do? If you want to hire people to work in your company or any other enlightened company wants to get into computer science, where do they get the staff? Okay, the people, the PhDs or even BS level of engineers that can think causally, okay? Not necessarily experts.
Do it,
okay? They don't exist.
Okay.
And why? Number one, the limitation of how much I can produce at UCLA. Then there is a problem of attention. If I go today to my dean or the chancellor of my university and I tell him, let's start a center in causal reasoning. They say, who needs causal reasoning? Students want data science, okay? Right. I'm not interested in that. Even if I have if I bring the money, okay? The attention is gone. So if you ask me what effect data science or deep learning has done on causal reasoning, they robbed us of attention. Nothing against them. They've done a good job and very successful. But at the same time, to go to the next level, we need to have the attention both of funders and of educators.
Right. Do you see maybe that we can change the game a little bit, and rather than relying on the few PhD students, could we not train AI agents to be able to do causal reasoning for us? Perhaps if an AI agent has seen, thousands or hundreds of thousands of causal problems, and we have had a human maybe, solve it, the AI agent, observed how they approached it, how did they apply the do operator, how did they build a counterfactual explanation. Could we maybe solve that problem and catch up with the deep learning community with AI agents instead of like trying to train humans?
To a certain degree, the GPT of today, or the chat GPT today, does that in a very sloppy way. Right. I give you an example, like I give you the famous canonical problem of the firing squad.
Yeah.
And I ask him, the prisoner is dead.
Right.
What would happen if rifleman one would refrain from shooting?
Right.
The first answer you'll give you is it's illegal to shoot in California.
Right.
Okay? So you have to be very careful, not how to. But then you try to prompt it, and you tell him, don't care about legality.
Yeah.
I want to know what happens to the prisoner. So it becomes better reasoner. If you prompt it good enough, eventually it will give you an answer which is a cookbook answers taken from some papers in philosophy. Tells you about names and slogans of over-identification. So it does it to a certain degree, but you have to prompt it properly.
Right.
Now, the art of prompting is still an art.
Right.
I don't know how to control it.
Right.
Okay. Some people are better, and they think it's a new science, the science of prompting it. Tell him that you are writing a
prompt
paper.
Engineer, yeah. And so, how do you see, high level, the interplay between, say, LLMs and causal models? How do they think they play together?
Let's not talk about LLM because we don't know what it is.
Got it.
Okay. But let's talk about deep learning.
Sure.
And let's talk about it's a functional approximator. If it's a functional, we know exactly how to use it. Because we can do ordinary causal inference. Every time the answer consists of a function, let's approximate it using deep learning.
Got it.
That is, for instance, take the backdoor formula. What is a backdoor formula? It's just an adjustment for a certain variable. It's a probability distribution. Go ahead and approximate this probability distribution. So we know exactly how to use it, in what context, and effectively. So that is, we know in that level, we know how to use it. If you want to use it in a higher level, we still don't know.
Actually, maybe you can talk a little bit about that. How when we do things like deep learning, we learn the distributions, and we may not be able to answer things on individual basis. But those seem to be, extremely important considerations in business, in healthcare, and I can think of a bunch of customers where we've enlightened them on this idea that, just learning a distribution, can help you answer things on average, but not for very specific situations.
Every decision making is a situation-specific decision making. You want to treat this particular question. You want to pacify this customer.
Yes.
And
not all of the customers.
Not all of the customers. Although
could be useful as well.
You get some information from the population, but you want to apply it to a specific. So in a simple case, you want to for instance, to choose customers for that would it will be retained if you give them an offer, and they will quit if you don't give them an offer. And you want to identify them, and you want to, but the purpose here, the target is find a customer that will act one way if I give him an incentive, and different way if I don't. And this is already a specific counterfactual question. Okay? Yes, if I do. No, if I don't. This, but on this individual. Forget about the population.
Yes.
Okay. So we have now a theory for that. We have bounds, and these bounds can direct decision makers. And the bounds are computable, and especially for people who are already are doing it using a causal model, either by learning, by discovery, or by making assumptions. If you already have a causal model, you can compute this bound without going in, doing any extra work.
Right.
And if you don't, if you want to do extra work, you combine observational and experimental data, and the combination gives you information on the specific individual. So it's doable. I only need to go to the FDA and convince them that this is a way of selecting, of developing drugs, and not the way it's being done today. We care about harm and benefit to patients. We don't care about maximizing the probability of survival.
Right.
It's easy to maximize the probability of survival. Just select those people who are immune, who will survive anyhow. Healthy people and young, okay? It's easy. But you need to spend your resources on those people who can be helped.
The individualized treatment effect.
Individual, yes. So that, it's a tough task to convince people who have been doing things differently for the past 2 centuries.
Yes. Yeah, so that's maybe a good segue into, how do you think about reaching artificial general intelligence? And how do you see causal methods, play into that end state of the AI field?
Well, first of all, I believe in general artificial intelligence. That one day we will be able to replicate all human function. Causal reasoning is important, but it's not sufficient. It has to be coupled with natural language understanding, with vision, with many other things. But it's one field where we have a science, and we have a framework, and we know what we are doing. So it is a necessary component, which has a science
backing.
Right. So it should be a role model to other facets of where we don't have this scientific backup or backbone.
If you were to guess, what industries do you feel causal reasoning will transform first?
I think it's going to be medicine.
Medicine.
Yes, it will. Personalized medicine, for example. Maybe not, because the medical business is very conservative. Maybe marketing will be even earlier. Yeah,
that's what we are finding. Is that
because people want to make
less
profit.
regulation.
And they don't have a scientific tradition which ties their hands.
Yes.
To which they have to pay lip service to. Okay.
Less lobbying. Less regulatory capture. That makes sense. I think perhaps for humanity it will be most impactful if we can transform healthcare and medicine, but perhaps the way of the world is such that marketing ends up being the first beneficiary.
Trail behind, that's right.
That's so funny.
Could you imagine talking to the New England Journal of Medicine? You should learn from
the marketing.
I think you are right. This is how things will develop.
I've thoroughly enjoyed this, and I'm sure the audience in a few weeks when we air this live for the first time will absolutely love this.
Yeah, I have one more advice. Don't read other books except the book of why.
Yeah.
You're gonna